All right, guys. In this video, I'm gonna tell you how to do the first Minitab assignment. Um, so this is the file that I uploaded on Canvas. It's called Minitab assignment number one simulation. I believe that's what it's called. So, when you have this file, I guess first thing you want to just put your name in. Okay, so put your name, for example, I'll put my name, Charlie. So you're supposed to directly edit this file. And then after you're done, you will submit your own edited version of this file. Okay. And then basically what you do is you just follow the instructions. Okay, so let's read it. Um, so the goal of this assignment is to conduct a simulation to investigate the sampling distribution of the sample mean, which we kind of covered in class already, right? The central limit theorem on X bar. By repeatedly sampling from the continuous probability distribution below, so you can see that the distribution is a chi-square distribution with 6 degrees of freedom, which you already know that it is a not a symmetric distribution, right? It is a skewed distribution. It's skewed to the right. So it tells you what to do in Minitab. Okay, so in Minitab, first you do this, second you do that. So let's go into Minitab first. Okay, let me share the other window. Um, okay, here it is. So you want to again type in app.minitab.com and then you will see this page. And then what you need to do is you type in your UTM email address. Okay. And then you sign in using your UTM credentials. Okay. And then you do all of that, approve it. Doesn't matter what you choose. Okay. And then you do a blank project. Okay. So I mean, you may want to save it or you may not. It doesn't matter. Okay. So this is the UI that you should be seeing. Okay. Um, So now let's look at the file and see what we should do. Okay, so let's go back to the file. Okay, so the file says that you want to first simulate a sample of size n is equal to 35 from this distribution. Okay, and then it tells you what to do. Okay, select calc random data from the top menu bar and then just type in 10,000 for number of rows to generate. Storing column, type in C1 to C35. Distribution, select chi-square. Degree of freedom, type 6, click OK. So you just do exactly all that. Okay, so let's try to do it in Minitab. Okay, so you do calc and then you do random data. Yeah, so number of rows of data to generate 10,000. Storing column C1 to C35. Distribution, you choose chi-square. Degree of freedom, type in 6, and then do OK. Okay, so you've successfully generated um, 10,000 data in each column, and then we have 35 columns. Okay, so that's what it did. That's all that it did. Okay, so that's the first step. And then let's go back to look at the second step. Okay, so the second step says that to compute the sample mean of these sample observations, you select calc and then row statistics from the top menu bar. And then you want to select mean and then input variables. You want to type C1 through C35. And then you want to store the result in the column 37. Okay, so let's just do that. So then let me share the other window. Oh, no, sorry. Um, this one. Okay, so now you want to do calc and then you want to do row statistics, right? And then do some input variables. Just type in C1 through C35, or you could just highlight all those columns. Okay. And then start result in type C37 and then click on OK. Statistics select mean, right? Because we're doing the sample means. Okay. So basically what this did is that this is the sample mean of those 35 numbers. Okay, essentially the mean of those 35 numbers, right? The 35 numbers in the first row. This is a mean of the 35 numbers in the second row. This is a mean of the 35 numbers in the third row, so on and so forth. So we have 10,000 means, all stored in this um, column called C37. Okay. Okay, so now let's go back and see what else do we need to do. Okay, so that's step number two, I guess. Okay, and yeah, okay. So now you just need to answer a few questions. Okay, so the first question says that use Minitab to find the following descriptive statistics for the sample means in column C37. And then the first question said the mean of the sample mean is what? Okay. The standard deviation of the sample mean is what? So remember, the sample mean is stored in that C37. So we're essentially just dealing with that C37, which is essentially 10,000 sample means. Okay. And then I want you to attach a Minitab output for the descriptive statistics. Okay. So essentially, if we attach the Minitab output, the mean and the standard deviation will be in the output. So let's just do that, and then those two will be obvious. Okay, so well, how do we get the descriptive statistics? Well, that's where this other files will come to play. There's an additional note on Minitab assignment number one. Okay, so let me open that file, and then let me share that file. I don't even know if that's necessary because I'm recording my screen, I think. Um, where is that file? Okay. Um, so it says that to get summary statistics, do stat basic statistics, display descriptive statistics, and then you select the designated column. Okay. So it's stat basic statistics, display descriptive statistics. So let's do that. So let me go back to this thing. Okay. Stat basic statistics, display descriptive statistics. Variable, you want to choose C37, right? And then by variable, I don't think you need to do anything with this one. So just click on OK. And then you will see that this little box shows up. Okay, so that's your summary statistics. So you just want to see the little upside down triangle. So click on that and then click on copy table. Okay, and then go back to your Word file. The Word file that we were editing. Not this one, sorry. What? This is silly. Yeah, okay. Um, okay, okay, so just do enter and then paste it here. Okay, just paste it here. Just paste this table here. That's it. Okay, that's it for this question. 2 points, right? Attach the Minitab output. So that's how you attach the Minitab output. And then from the Minitab output, okay, it gives you a mean, it gives you a standard deviation, see? So the mean standard deviation. So let's just type that in, okay? So the mean of the sample means is what? Well, let me use red color. That would be 6.00570. Okay, in my case. So these data, again, are randomly generated. Okay, so the sample mean that you have will be different from what I have. Okay, it is impossible that we have exactly the same number. Okay, so if you just type this number in, then I know that you're just I mean, there's no way. You have to do it. Okay, you can't just like be typing this number in and that's it. You have to actually do the table, and then from your table you look at the answer. You can't just copy and paste my answer. Okay, so that'll give you a 0 point on this question. So the standard deviation of the mean is you just type in. Okay, so type in 0.593291, which is this number right here. Okay, so it's not difficult, right? Okay, so then let's do step number two or question number two. Okay, it said that it wants you to create and attach a histogram and normal probability plot for the sample means in column C37, 1 point each. Okay, so you're supposed to attach both, okay, a histogram and a normal probability plot. Okay, so how do we do that? Well, we refer to the additional notes, which is, I guess I minimized it. Okay, so let me share this one. Additional note, okay? Um, so number two, okay, so to plot a histogram, you want to do graph and then go to histogram, go to simple, and then select the designated column. Okay, graph, histogram, simple. Okay, so let's do that. Okay, so graph, histogram, simple. Okay. Y variable, you want to select C37, select that, do OK. Okay, so that's a histogram. See? Okay. So what I want you to do is just you copy this graph, okay? And then you go back to your file, not this file, the other one. Okay, so you want to just paste it here. Okay, paste it here. So that is your histogram. Okay, that is your histogram. And then the other one that you want to do is the normal probability plot. So how do we do that? Well, go back to that file, right? Damn it. Um, okay. To construct a normal probability plot, do graph, probability plot, simple. Okay. And then do normal for distribution, which is the default. So graph, probability plot, simple. So let's do that. Okay, so finally I can close this file because I don't think I'm gonna use it anymore. Oh, uh, hmm, I guess I can just stop sharing. Where is it again? Okay. Let me close this one first. Okay. Okay, so now let's go to the Minitab. Okay. So the graph, and then what do you want to do? You want to do probability plot, simple. Okay. And then distribution by default is normal. Okay. By default is normal. So you don't need to change that. And then for Y variable, you do C37, select that, and then do OK. Okay, so that gives you a probability plot of C37. Okay, so let's copy this graph and then let's paste it back to our file. Mm, which is this one. Okay, so let's just paste. Okay, do Control V or Command V if you're using Mac, or just click on paste. Okay, so that's it for number two, right? So attach. I mean, part one of number two, I guess. Which it wants you to create and attach a histogram and a probability plot. That's a histogram, that's a probability plot, so we're good. And then it asks you to answer some questions. Is the distribution of the sample means approximately normal? Okay. So that's a yes or no question. Okay. If you think it's a yes, it's a yes. If you think it's a no, it's a no. Simple. You either write a yes or a no. Um, in our graph though, okay, this does look like a bell-shaped, right? Symmetric thing. So I would probably say yes, okay, to this question. And then the next question asks you to explain your answer by referring to both the histogram and the normal probability plot. Okay. So that you need to explain using both of the plots, okay, not just one, because it's 1 point each. Okay. So looking at the histogram, okay, if you said yes, which I think, um, I mean, according to the theorem, it's definitely a yes. But if you want to say a no, that's fine as long as you give your reasoning. Okay. So you could say, it's not that symmetric or something like that. But here I would argue yes. So I would say that it is symmetric and bell-shaped. Okay. It's shaped like a normal distribution. And then for the normal probability plot, you still need to argue if it's a yes or a no. Okay, so if I said yes, then I would say, okay, look at all the points. They're roughly in a straight line. Okay, so that's how we read the normal probability plot through eyeballing, right? So yeah, I would say yes. So here actually you can also argue no. If you want to argue no, then you look at the p-value. Okay, so this is a normal test. Okay, so in a normal test, in a test for normality, the null hypothesis is that the distribution is normal. Okay, the distribution is normal. The underlying distribution is normal. Okay. So if p-value is small, we reject the null. Okay, remember we learned that in class, right? When p-value is small, we reject the null hypothesis and we conclude the alternative, which is that the distribution is not normal. Okay, so you can argue that as well. Okay, so there are different things that you can argue. And I'll tell you why the normality test failed. It's because we're having 10,000 means. Okay, it's a large sample. So our hypothesis test will be very sensitive, right? Because we had one question in class. Okay, if you still remember, the McDonald's versus Burger King, or actually Burger King versus McDonald's question. So Burger King in the sample data, it has a 91% order accuracy, right? Sample order accuracy. For McDonald's, it's 93%. 91, 93, not that much of a difference. But the thing is, we have 10,000 data points. Okay. So that makes that, so that, because we have a big data set, that magnifies the difference. Okay, so even a 2% difference is large enough to be called different, like statistically significantly different. Okay, so same thing here. Okay, even though it's not that far away from normal, but we have 10,000 points. So even a little bit of discrepancy from the theoretical normal distribution would make it look like it's not normal. Okay, so that's why. But anyways, you can argue either way. I would argue yes, mostly because it does look normal. Okay, but if you want to go into technicality, okay, go to technical details, then I guess you can also argue no. Okay, that's enough for that. I spent too much time on that. Okay, so for question number three, okay, this one's a little tricky. Okay, so what you do is um, it wants you to estimate the probability of observing a sample that is at least 5.0. I think there are multiple ways to do it. There should be a way to do it in Minitab, which you can figure out if you want to do it that way. What I'm going to show you is a easier way. Okay, so what you do is that if you still remember, okay, we learned that in class that I'm just gonna write it here. Okay, let me find it. Equation. Okay, you still remember, um, x bar, x, um, okay, so x bar approximately follows a normal distribution with mean, okay, with mean of x bar equals to mu, right? The population mean. And then with the standard deviation of x bar, okay, equals to sigma divided by square root of n. Okay, if you still remember that, which you need to remember that. Okay, so what is mu here? Well, mu here, we know that we have a what? A chi-square distribution, right? So for a chi-square distribution, the population mean is equal to the degree of freedom. So here is actually equal to 6. Okay, so for a chi-square distribution, the population standard deviation is equal to the square root of 2 times the degree of freedom. So actually sigma here is the square root of 12. Okay. And then n here is what? N here is 35, remember? Because we have 35 columns, right? So then this number is equal to, whatever this number is equal to. Okay, you calculate that. Okay, you calculate that. Well, okay, let me just calculate it here, actually. Let's see. Square root, square root, square root, 12 minus 35. Okay, so that is about point 5855. Okay. That's that. Okay. So now you know the theoretical distribution of the mean. Okay. Um of the sample mean. Okay, so now what I'm asking is what is the probability that this X bar thing, that this X bar is at least 5, so larger than 5. What do you do? You should know what to do. Okay, you should know what to do starting from here. Okay, we've covered this in class, so I'm sure you know what to do. Okay, so that's the whole thing for this Minitab assignment. So of course you want to, I mean, I talked through this, but since you can argue either way, I didn't really write a definitive answer, but you should know what to write by now, okay? And then for this guy, of course, you calculate this probability, and then you explain your answer, show your work. Well, that's explaining your answer, showing your work part. So yeah, I showed you everything. So we're good. Okay. So if you have any questions, let me know. If you don't know how to use Minitab, there's the other video that you need to check out, like how to set up Minitab. Um, yeah, that's it for this video.